Jak słyszeliście Państwo, technologie się przydają. Przydają się do tego, żeby się rozwijać, żeby podejmować kolejne innowacyjne działania. Przydają się też do tego, żeby te działania monitorować i to w czasie rzeczywistym. Na przykład stan wód opadowych. Dzięki takim technologiom można monitorować. Jak to robić i przede wszystkim po co? O tym opowie pan Aleksander Buddrick z firmy Nivus.
Yeah, good morning from my side. Thank you, Stefano, for opening up this very important topic of water quality in stormwater and sewage water. And this is also my topic today, where I'm presenting you a new technology in better detecting the quality in your runoff. My name is Alexander Buddrick. I'm with Nivus from Germany, and we have also a booth here with our subsidiary, and I'm inviting you to join me later. And also, please let me thank you very much for this high-quality conference. I'm really, really honored to be here and speaking to you. And I learned a lot about the Polish market yesterday, so it gives me good connection points for my speech today. This morning, I did take a run along the Warta River here in Posen, and I was wondering whether somebody of you did take a swim this year already in a Polish river. So you might raise your hand. Can't see anyone now. Maybe last year. Oh, I have one hand here. Wow, wonderful. Wojtek yesterday already pointed out that his experiences in Krakow were not the funniest ones. And I would maybe go into swimming into the water, but definitely not after a heavy rain event. And this simply for the fact that the heavy rain situations cause a lot of pollution into our nature rivers, because our systems get stressed by spillovers. And the topic for today is looking into quality. And maybe who of you may not know Nivus. Nivus is a SME company, and our vision is to focus on preserving water as a source of life and nature. And everything we do, we want to do together with the customers to do it the best way, to improve the water circle and protect from water-related hazards. And one last slide to Nivus so you get a little bit of an idea. So we are coming from measuring technology, and one of our core products is the Nivus Flow system, where we get high precise, high accurate flow profiles and can get high accuracy in you measuring the flow volume of sewage water, waste, rainwater, and surface water as well. So let's switch over to the topic. Environmental pollution is a core topic, and even in Germany 4 years ago, or already 5 years ago, there was issued a new worksheet called A102, and this set new standards for stormwater treatment, especially the focus on so-called abfiltrierbare Stoffe, AFS, or in English, total suspended solids, with a very fine solids sizes from 0.45 micrometers up to 63 micrometers are considered as very important variable to be measured. And this is simply for the fact that these values, these particles often contain micropollutants like heavy metals, like polycyclic aromatic hydrocarbons. And in Germany, we have not a good state of our chemical state of our waters. And I've learned yesterday that Poland is not better than Germany. So we have to focus on these fine solids, and we have to do all of that because we want to meet our wastewater treatment directive given by the EU 25 years ago. So I ask you now if it's working. It's not working. Let me see. No, it's not working. I was trying to set up a Mentimeter to give you the chance to do a poll, but it's not working. Anyway, let's go forward. Let's dive into total suspended solids a bit more. You can see a picture on the left side here. Total suspended solids are these particles that just, get into the rainwater from, Stefano told us, from the streets or from industry. And in urban drainage, they are considered to be a very important parameter. And why that? Because the total suspended solids give us a good indication of the quality of the water because, as mentioned, it contains the micropollutants like the polycyclic aromatic hydrocarbons, nitrogens, pathogens, heavy metals, even inorganics like sands. Sand is part of total suspended solids. And this is also the reason why in the just recently given new urban wastewater treatment directive by the EU, this is also a focus parameter to be monitored. So how could we go forward as an industry and detecting or measuring this better? There's actually only one measuring method, and it's the laboratory analysis. And you know that, like, to take samples, there's a sample wagon outside the building. You take the samples, you sieve it, you try to weigh it, and then you have the concentration, the absolute correct information. The disadvantages of this approach is it is far too expensive, it's long-lasting, and it is not continuous. So that's the main challenge here. And this is why we should have a look in so-called surrogate alternative measurement methods. And there are a few ones that I'm presenting here. The one is optical backscattering technology, so turbidity sensors. They use infrared lights with an optical glass and try to measure the size and composition. Challenge here is cleaning the sensors all day long. Second technology, single frequency acoustic backscattering. It's ultrasonic, but only with a single frequency, so you only get a small picture of the whole particle distribution. And third, laser diffraction, another optical system that needs to be maintained regularly. And my focus is going to our multi-frequency ultrasound backscattering technology. And why is that? The biggest challenge we have with total suspended solids is that we have a wide distribution of the particle sizes. I've brought a picture with you from 24 samples of one rain event. And you can see here that for the median value, you have a span of from 20 micrometers up to 100 micrometers of particle sizes. So your measurement technology should be able to capture this whole variety in order to really get an understanding of the pollution load. So sampling processes also bring their disadvantages with it. Depending on how you do the sampling, you also change the result. But you can see here, take any of those samples from this 24 samples, and you will have a single picture of what the actual problem is. And we can conclude that to get a full picture of total suspended solids, it's not done with taking single probes, single samples, and deriving the total concentration. And that's where, when knowing that, we can set the following requirements to measuring total suspended solids. It should be continuous. It should give us continuous online information about the pollution load. It should have no drifting inside, like lenses that can get dirty, that drift away from the results drift away. It should have a high resolution capability, as you have seen in the particle size distribution chart. So we need to capture the full picture. Third, you should have no maintenance, virtually no maintenance to do so. And lastly, you also should have explosion protection within the system, as you have to do with sewage water in the end. And all of that is then relevant for being able to become more smart in stormwater management. We cannot treat all our stormwater in our treatment plants. There is good stormwater that can directly be being brought into nature, but there's bad stormwater, polluted stormwater that needs to be treated. And there is not always a first flush means if you think of, okay, we'll take the first bunch of the rainwater coming into our system and the second part can be dissolved into nature, can be brought into nature. This is also a wrong understanding. So that's why we took these requirements and developed the technology, which I'm presenting you now. So this is the Nivus Park 850 sensor. We use a multi-frequency technology. So we use 7 frequencies that continuously send the signals into the water. We measure the backscattering signals, and we can then calculate the particle concentration, the particle volume out of that by these signals. And if we know the particle volume, and we multiply it with the mass density, which is given for stormwater runoff, then we get to the particle concentration online. So that's the system we already have in place. And it looks as a complete system like this. We have the data logger that is using, collecting the data, applying this multi-frequency backscattering technology without a drift, almost no influence by the particle size distribution, and no maintenance. What we require actually is 8 centimeters of water level for the sensor to actually measure. And this system also has X protection, which is not shown here. So this is now how the system looks like. And I want to show you some regression curves to show you also the quality of the system. So what we did here is we did lab tests for 3 classes of total suspended solids, which you can see on the 3 colors. And you can see the strong linear relationship between the total suspended solids equivalent on the y-axis compared to the real total suspended solids on the x-axis. So there's a high and strong linear relationship. So using this technology, we are able to really measure the pollution load of the water. And there's almost no or low impact by the technology. So now we understand total suspended solids and how to measure it. But why? Why should we do that? So let's have a look into regulation. And this is a picture from Germany, Poland, the border area. And this is giving us a feedback on the water quality of the rivers in Germany. And you can see here there's almost, no good quality. There's Posen on the red top. And we heard a lot about regulations yesterday and lacking regulation, and which was a bit of surprising to me. We have the Water Framework Directive that for us in Germany gives a very bad, or we have a bad answer to that, yet still in Germany, only 9.2 waters are in good or very good shape. And the problem with that directive, in fact, is that there are no consequences for the emittents directly. And this is why we could be happy that we now have a new directive given by the EU that tries to regulate it European Union-wide. You can see here the voting result from November last year. It was in almost unity, except for Hungary and Poland, that tries to focus on regulating pollution into nature by 2% maximum in volume, but also in pollution load. So we no longer focus only on volume, but also we need to focus on how much pollution load particles we are, spilling over in nature. And there are many more regulations that are very interesting, like the manufacturer responsibility, which brings in money into the game, but also like this one that we have to monitor, we have to start monitor discharge points intentionally. And it includes a emitters perspective. And this gets into effect by July 2027, or April, I'm not sure, but 2027 it needs to be brought into national law. And I'm looking forward to it because it helps us to getting better in our stormwater treatment in general. So why do we measure, or why should we measure online? I mean, as you may have got an understanding, with having online hydrograph data like this, the blue, the orange curve is the flow volume, and the blue curve is the pollution load. You can get a better understanding for your system actually. Continuous measurements help you prioritizing actions. With this concentration graph, you can actually start developing treatment strategies, or develop new ones, or even implement real-time control systems. And there's already one scientific work being done by a partner of us, presented at the ICUD last year. So in fact, if you have your network, like on this screen, and you have an identification of where do you have the most problems with pollution load, you can start doing measures. You should not start doing something like investing in concrete without knowing whether you actually have the problem. So that's why we pledge for monitoring the relevant discharge points, for example, to identify where do you have the most problems in your system. And only then you can set up effective measures for new or for existing constructions. So to conclude, and I'm mostly right in time, the new treatment directive, the European Urban Wastewater Treatment Directive, requires us to improve on flow volume and pollution load discharge. And it helps us to think about economic and ecological solution. We cannot build retention basins all day long. We don't have the money for it and the space, as I heard from Vinny's, for example. Our pledge is to start measuring now. We need to gather high quality data for being able to derive measures from it. Third one, this online data helps you to really prioritize what you have to do in your stormwater systems. And lastly, only with real-time data, you're really able to make smart real-time solutions to keep track of your changes and to improve the overall system. So thank you very much for your questions, for your attention. If you have questions, yeah, please visit our booth over there. Thank you.